This is going to be another how-to, very short video on creating an out-of-range function. This is a different way of doing it that I've just unearthed. So I was using the Stanford Dragon model, which was either got for me by or Graham Dretch, I can't remember which, and converted in MeshLab, but it comes originally from the Stanford scanning repository. And we've got default lighting and default grey material on it. And I'm going to use the diffuse channel to demonstrate this. So I need a function in here which I can modify. So use basic and check blue because that doesn't have any phase functions in it that do anything. It's got phase in it, but it's got nothing in that, so it's just a nice clean function to start with. And I'm going to modify this initial noise to nothing and then set a sine filter in here and use the sine filter. I'll just turn off colour and bump so you can see what's happening with the alpha channel, and take it down to fully black. And then I'll drag the first component over to the second component, reset the sine filter, and take it up to fully white, and then use, well, I'll start with a blend curvature so you can see the effect of it going from alpha black to alpha white, and then I'll use fast curvature, and you can see you've got these successive bands. And these successive bands are the Deep Texture Editor thumbnail trying to display out of range values. And it works out of range in either respect, white to black or black to white, but obviously one's positive and one's negative. Well, I don't know, it's obvious, but you can test it and demonstrate, and it makes sense that it should be that way anyway, because obviously it's running either downhill or uphill on the curvature. So with this set now, and remembering you've got different functions here that affect the way it displays, obviously on a sphere, it's got continuous curvature, so you don't really see the effect. But if we check out of here and render, you can see the effect on our dragon. And you'll notice that the default grey material in parts looks white. And this is the point at which you can test whether this is out of range or not. Because under default Bryce lighting, if you set the diffuse colour to, well, any colour, but I'm going to use a sort of an orangey colour here, so this sort of range, then under 100 sunlight you'll get that colour returning on the brightest part of the object that's lit. However, you'll notice that I included some green. Now if it goes over the top you get the hue shift due to the excessive lighting of the material, and it's pushed the green up and you'll see yellow, and this is exactly what you can see in this example. So this demonstrates that you could generate an out of range function. The other thing you could do to show that it was working in the opposite sense is you could introduce ambient control here, and then you could detect for whether or not you were producing any negative ambient. So I've just got that on diffuse, now we'll do it with ambient, and you can see that's lit up. Now if I wanted to check the other function was negative, I'll go in here, I'll just swap white for black, black for white. So now instead of running positive we're running to negative. Then when the ambient comes in, it'll actually start subtracting from the surface, so you get some weird negation effect. So these outer edges, which would have been lit, have had light pulled off them from the ambient channel. You can prove that here, and you can get rid of that. And you can also see some quite high values of ambient have been generated. So I'll just put it into green, so you can see that we've got high values of ambient generated and also light subtraction occurring. So if I put that back into white or grey, you can see that it's pulled the light off the surface. So there's just a brief overview of ways of generating out of range values from the curvature filter. You'll notice the appearance of the dragon is quite faceted now, even though the dragon is smoothed. You get a different effect if you unsmooth the dragon. And the reason for that is the curvature filter doesn't recognise the smoothing algorithm that's used to generate the smoothing effect on mesh models. So that's actually a flaw in the way that the curvature filter works. It works perfectly well with bump, but not with geometry quite so well. You need very high resolution geometry to get rid of this faceted appearance, though of course you could use that to your advantage in an effect if you wanted to get this kind of faceted appearance. So there you go. There's a way of producing positive and negative out of range outputs from the curvature filter, and bearing in mind all the other ways the curvature filter works. So you've got those controls as well. If I just go over those there, so you can incorporate this with any combination of these controls, which means you've got quite a powerful tool there for creating different effects. So I hope you found that interesting and that you'll have a go at experimenting with this in your own renders.